All right, welcome to lesson 1.1. We're looking at radical expressions, and we're going to be specifically looking at how to rationalize the denominators. You have taken a look at this before, so we're going to take a look first at rules for simplifying radical expressions in general, and then we're going to look at how we rationalize denominators in advanced functions, and then we're going to look at how to rationalize binomial denominators. So first, heading back to grade 11, how do we simplify radical expressions? In our first example, we're looking at how do I change to simplest form. And we do that by finding a perfect square factor. So when I look at the square root of 162, I kind of go through my list of perfect squares. So I'm looking at 1 squared obviously isn't going to make a difference, but 2 squared, 3 squared, 4 squared, 5 squared, etc. And what I'm looking for is the biggest perfect square I can find that divides 162. So you might notice that 162 is divisible by 81. So I can rewrite this root, instead of 162, I can rewrite this as 81 times 2. And this is convenient because I know that the rules of radicals tell me that I can split the radical across the multiplication. So I can rewrite this as the square root of 81 times the square root of 2, and then I can take the square root of 81. That's why we chose to divide by a perfect square factor. I can take the square root of 81, it's just 9. And so the square root of 162 is the same as 9 root 2. Now, some people might not have noticed that 81 was a perfect square. So another possible solution for this question would be the first step saying that 162 is divisible by 9. So they might have noticed the 9 first and gotten 9 times 18. They're going to end up with the same answer as me at the end, but they're going to take way more steps to do it. So this is root 9 times root 18. Which is the same as 3 root 18. But then when you look at 18, you're like, oh, I can divide that by 9. So we'll rewrite that as 9 times 2. And again, you bring the 9 out and square root it, and you get a 3 times still the square root of 2. And now you've got 9 root 2 as we did over here. So you'll notice here that I did skip a step that I showed before. Here I'm showing the step of writing out the root 9 times the root 18, and here I skipped over writing root 9 and I just went right to root 3. So I'm fine with that. If you wanted to skip this step here and go straight from here to here, just be careful that you actually do take the square root of 9 when you pull it out of the root. Same thing here, if you wanted to skip right from this step to this step, that's fine with me. But make sure that you're in a place where you're ready to do that. All right, so for our next question, we're looking at adding and subtracting. We can only add and subtract like radicals. So that means that they have to have the same number underneath the square root. So the first thing I'm going to do here is reorganize this list and put my like radicals together. So root 2 is my first term, and a like root would be 3 root 2. It's a positive 3 root 2, so I'll bring that with it. And then here my other two terms are minus 3 root 5 and plus 2 root 5. So because they're both root 5s, I'm also going to collect those together. And then I can just say here I've got 1 root 2 and I'm adding 3 more root 2s, so I have 4 root 2s. And here I've got negative 3 root 5s and I'm adding 2 root 5s. So negative 3 plus 2, that gives me negative 1 root 5s. And you can write the 1 if you want, but I find it simpler just to get rid of the 1 coefficients. All right, the next thing that we're going to review is multiplying. Now we kind of looked at multiplication here, how you can separate, and of course we could go backwards with this. So if I had root 81 times root 2, I can put that together under one root and say that that's the same as root 162. So we're going to use that skill within a multiplication of binomials. When I'm multiplying the binomials, first I'm going to start with root 2 and I'm going to multiply it into the second bracket. So root 2 times root 3, again I can just multiply the numbers under the root, so it just becomes root 6. And then I'll do root 2 times 2 root 2. Now here there's a coefficient, so what I do for this is I multiply the two coefficients together. The coefficient here is 1, so 1 times 2, that gives me 2, and it is positive. And then I multiply the numbers under the root. So root 2 times root 2, that's a root 4. Next I'm going to multiply the negative 3 root 6 times root 3. So negative 3 is the coefficient times the coefficient of 1, that gives me negative 3. And then under the square root, I've got 6 times 3, so that's root 18. And then negative 3 root 6 times 2 root 2, so negative 3 times the positive 2 coefficient, that gives me negative 6. And then multiplying the numbers under the roots, 6 times 2, that gives me 12. And now I'm going to see what I can do to simplify this. So root 6, there's no perfect square that divides 6, so that's in simplest form. Then I've got 2 root 4. Well, root 4, I can take the square root of 4, so that's just 2 times 2. And then here I've got root 18. We saw up here I can simplify root 18. Root 18, that's the same as 9 times 2 under the root. And then when I look at 12, again, I'm going to ask myself, is there a perfect square that I can divide 12 by? And there is. I can divide by 4. So I'm going to rewrite 12 as 4 times 3. And now I'm going to simplify these guys. So here I've got 2 times 2, that's 4. Here I'm going to bring out I'm going to take out the square root of 9. So that becomes times 3. And then I'm still multiplying by the square root of 2. And then here I'm going to take the square root of 4, that's a 2, and then I've still got the square root of 3. So cleaning up again, now I've got 3 times 3, that's 9 root 2, and 6 times 2, that's 12 root 3. All of these roots are in simplest form, there's no perfect square I can divide them by, and there's no like roots for me to collect, so I'm actually done here. This is in simplest form. Moving on, I'm going to take a look at this difference of squares pattern. So what happens when I've got like a root minus a root times the same root plus the same root? So I can see this kind of looks like that, x minus y and x plus y. So we'll multiply this out here. Again, I'm going to do the root 5 times root 5, and I get root 25. And then I'm going to do root 5 times root 7. It's positive, so it's root 35. And then I'm going to be looking at negative root 7 times 5. That's negative root 35. And then negative root 7 times positive root 7. That's negative root 49. So when I simplify this, I can take the square root of 25. And then what I notice here is I've got plus root 35 and minus root 35. Those guys are going to cancel each other out to 0. That goes away. And I'm just left with minus root 49, which again, I can take the square root of 49. And I'm left with negative 2. And so what we notice here is I started with something that looked rather complicated and I ended up with something really simple. So this is actually a super handy little trick that we're going to use later on. That difference of squares pattern. All right, so that's the end of our grade 11 review. Now we're going to take a look at some advanced functions review. So in advanced functions, we rationalized one-term denominators. So what we did here was we multiplied by what we call in math a convenient form of 1. So what I can do without changing this expression is I can take that same expression and multiply by something that's equal to 1. So here, in order to come up with that expression, we're going to use the radical from the given denominator. So the radical in the denominator is root 5. So I'm going to multiply by root 5 over root 5. Notice that this is just multiplying by 1, right? Nothing here is actually changing the value of this expression. And now I'm just going to multiply fractions, so I'm just multiplying the numerators together. Again, I can multiply the numbers under the roots together, and then in the denominator, same thing. Then I'm going to simplify. I can't simplify root 15. There's no perfect square that divides 15, so that's in simplest form already. And on the bottom, I've just got 3 times 5. And so this comes out to 2 root 15 over 15. Okay. And again, I did check that root 15 was in simplest form. And so we're done. All right, so new in this course, what happens when I have a two-term denominator? So you can see in our examples here, I'm going to have like a root minus a root. Here I've got just a number minus a root. What we're going to do is, again, multiply by that convenient form of 1. So I can only multiply by 1 if I don't want to change anything. So in this case, to come up with my convenient form of 1, I'm going to use something called the conjugate of the given denominator. So the conjugate is related to that difference of squares pattern that we saw in the first example. If we create that difference of squares pattern in the denominator, like in that example 1 part D, we'll eliminate the radicals in the denominator. Remember, it just came out to -2. This is what we call multiplying by the conjugate in math. And so in this course, we're looking at multiplying by radical conjugates, but there are other types of conjugates as you get into higher levels of math. So for radical conjugates, if I start with the expression a root m plus b root n, then the conjugate is a root m minus b root n. So it's just making a difference of squares pattern. So what I'm going to do to simplify this expression here is I'll take the original fraction and I'm going to multiply. I want to create that difference of squares in the denominator in order to simplify it. But if I multiply the bottom by that, I need to multiply the top by that. So I'm actually only multiplying by 1, right? This whole second fraction is equal to 1, and so I'm not actually changing the value of the first fraction. And now I'm going to expand this out. So when I do that, I need to remember that there are invisible brackets around these binomials. You don't have to add those in, but you do need to be aware of them. So when I multiply 2 root 2 times the second numerator, I'm multiplying 2 root 2 times the first term and 2 root 2 by the second term. So I've got 2 root 6 plus 2 root 10. In the denominator, I'm going to have that difference of squares pattern. I know that the middle terms are always going to cancel out when I create this difference of squares pattern. I'm going to have root 3 times root 3, so that's root 9, which is the same as 3. So you might also be thinking about root 3 squared, and then the root and the squaring cancel out, and you're just left with 3. And then I'm going to end up with positive root 15 and subtracting root 15. I'm not going to write that down. I know that it's going to cancel out because I created this way. Then I've got negative root 5 times positive root 5, so that's going to be a negative, and root 5 times root 5, that's just 5. And again, I've gotten rid of those roots in the denominators. So now I'm just going to clean this up. I've got 2 root 6 plus 2 root 10. Those are both in simplest form. If there was some simplifying to do, I would do that. Oh, actually, I'm going to erase that. Hopefully you didn't copy it yet. What I can do to simplify this is I could take out a common factor of 2. They both have that 2 coefficient. And you could do that in the line below as well. In the denominator here, I get 3 minus 5, that's negative root 2. And so I took out the common factor because I noticed that they were going to cancel. The 2 on the top is now a multiplication of 2, not an addition like these ones. And so I can cancel it with the 2 in the denominator. And then I'm just going to pop that negative up front. So I've got negative 1 now as my coefficient. And I'm done. All right, so we're going to try the same trick here with this second one. Again, I've got a root in the denominator, but it's a binomial. So in order to get rid of it, I'm going to multiply by the conjugate of 1 minus 3 root 2. So the conjugate of that is going to be 1 plus 3 root 2. So I'm just switching. If it had been 1 plus 3 root 2, I would change to 1 minus 3 root 2. Again, I'm going to multiply 2 root 3 by both terms in the second numerator. And then I'm going to FOIL out or expand out this difference of squares in the denominator. Again, what's going to happen is I'm going to get 1 times 1 is 1. And then I'm going to get positive 3 root 2 and minus 3 root 2. And those guys are going to cancel out. So I'm just left with taking the negative 3 root 2 times the positive 3 root 2. That's going to give me a negative. And then I multiply the coefficients together, 9, and multiply the numbers under the roots together, 4. And now I'm going to try and simplify this. Again, in the numerator, I've got that common factor of 2. So I'm left with root 3 plus 3 root 6. I can't simplify either of those roots, 3 or 6, so I'm done simplifying that. And then in the denominator here, I've got 1 times 9 times root 4, so that's 9 times 2, or 18. And so altogether that gives me negative 17. Instead of writing the negative in the denominator, though, I'm going to pop it up to the numerator for simplest form. All right, so that one is done there. Part C, we're going to do the same thing. This time we have an addition in the denominator. But we start the same way, just copying down the original. And now I'm going to multiply. I want to create that difference of squares, so this time I need to switch it to subtraction. And now remembering about those invisible brackets, right? So I actually have a binomial times a binomial in the numerator here. This one's a bit more of a pain in the bum. We got to expand that out. So I've got root 3 times both of the terms in the numerator. And then I've got 4 root 2 times both of the terms in the numerator. In the denominator, I know that when I expand this out again, the middle terms are going to cancel out. So I'm just going to have to worry about the first term times the first term. So that'll be 4 root 4. And then the last term times the last term. So again, that should always come out as a subtraction, right? Because you've got the different signs. And then root 3 times root 3. And you can be thinking about that as root 3 squared if you want, or just go right to 3 is fine. So now I'm going to try and simplify this out. What I notice here is I do have 2 terms with a root 6. So I'm going to put those guys together. 2 root 6's subtract 4 root 6's. That's minus 2 root 6. And then the root 9 I can actually simplify to just being 3. And then again here I've got 8 times root 4. I can just simplify that to 2. And then in the denominator, we've got 4 times the square root of 4 is 2, minus the square root of 9 is just 3. So we're getting there, a little bit simpler. In the numerator here, I've got negative 2 root 6. And here 8 times 2 is 16, minus 3 is 13. And then in the denominator, I've got 4 times 2, that's 8, minus 3, that gives me 5. So to clean this up just in simplest form, typically we wouldn't lead here with the minus 2. I would change this around to 13 minus 2 root 6, but that's just a minor thing. I would not take off a mark for that. If you left it on this line, that would be fine. And that's it for today's lesson. You can find the homework on the homework log. Enjoy!